Welcome back to quantum computing. In the previous lecture, we learnt about how Pauli-X gate works and what its mechanism and how it represents in matrix form. Now we'll focus on Pauli-Y gate. Okay. Before going to Pauli-Y gate, I'll just need to give the basic understanding. So if you apply a Pauli-Y gate on two input states, 0 state and 1 state, 0 state will result in I oblique 1 state. Why it represents I oblique 1 state? If you remember, it is flipping the phase. That means it flips the phase of the bit. And one state is becoming 0. Correct? But you will be wondering how I have come as their output. Correct? So let's understand what is Pauli-Y gate. Pauli-Y gate. It is a bit phase flip. So it will flips the phase of a bit. Okay. So to work on quantum computing, for every gate there will be a mathematical representation, none other than matrix representation. So here also we need to understand matrix representation. Okay. Y gate. Again same. Y gate will be denoted like this. So the matrix representation is 0 minus I plus I 0. Correct? Good. So again, it is very important to remember the mathematical matrix representation notation for each and every gate. Earlier in previous lecture, we understood about X gate. Now here we are going to work on Y gate. Further still there will be Z gate, Hadamard gate, C0 gate, Pauli gate and so on. I'll explain each and every gate in clearly, so no need to bother about that. So let's focus on understanding Pauli-Y gate. So if you want to understand the Pauli-Y gate, remember this matrix representation. Okay. Now what I said in Pauli-Y gate, so it flips the qubit state. It flips the qubit state while introducing a phase shift. Okay, while introducing a phase shift. Now, so we know how the qubit 0 will be represented 1 0 and how 1 will be represented 0 1. So this is your input. Second, now you need to apply Y gate on these inputs. Correct? So Y oblique 0. So what is the Y representation in matrix? It is here. So again, remember Y is also a 2 into 2 matrix. Why I am mentioning the 2 into 2, 2 into 2 from all previous lecture. In further classes, we'll be working on 4 into 4, 8 into 8 matrix also. So from starting onwards, you need to identify which are the gates that have 2 into 2 matrix, which are the gates that is having 4 into 4 matrix, which are the gates that is having 8 into 8 matrix. So that is the reason I again keep on telling the matrix representation size. Okay, so Pauli-Y gate is also 2 into 2 matrix representation. Now apply the Pauli-Y gate here. 0 minus I plus I plus I is I and 0. 1, 0. Again, it's basic mathematical multiplication. It will result in what happens here? 0 into anything 0, minus I into 0 is 0, I into 1 is I, 0 into 0 is 0, correct? Where I is there, it is there when it is there in one state, because it is there in the second row, which is one state. So you can write this in I oblique 1. Can I write or not? Why? You can see. You can cross verify this. You can cross verify. So even in some cases, even if you are not knowing that whether the value is correct or not, you can cross verify it with simple mathematical from scratch again. So you know that you got a output I. So how does you represent one state? You know that one will be 0 and 1. So if you multiply I with this, what will be the output? 0 and I. So both the answer matches. So this representation is correct. Similarly, now I explained about Pauli-Y gate on 0 qubit. Now Pauli-Y gate on first qubit. So Y gate is 0 minus I 0 into 1. How you can write 1 qubit 0 1? This is how you represent in matrix. Okay, again, yeah, sorry, I forgot to mention the output will be resultant in 2 into 1 matrix. So again, same mathematics to be applied here. 0 into anything is 0, minus I into 1 is minus I, 0 into anything is 0. So now, how can we represent this? Simple. Get the minus I outside, write it as 0. Correct? Correct or not? It's correct. You can verify it. Minus I, you know how to write the 0 gate. 1, 0. So it will be minus I into 0, 0. Perfect. Now, you guys will be wondering how come it flips the gate as well as phase. Correct, right? Because that is the reason it has a name bit phase flip. So it will flips the bit. That means 0th bit is flipping into 1 bit and its phase also. Correct? Input we are passing as 1 zeros or 0 ones, but output is resulting in ith phase. That means polyphase. Correct? You can see here output is resulting in phase. That is why it is called as bit phase flip. Okay. Uh, that's all for the day. In the next class, we'll understand Pauli-Z gate. It is also called as phase flip gate, whereas Pauli-Y gate is called as bit phase flip gate. Pauli-Y gate, phase flip gate. Okay. See you guys in next video. Thanks for watching. Do subscribe, like, share, comment. Thank you.